Now let's talk about neutralization reactions, which are acid-base reactions. An acid and a base react to produce a salt and water, which means they neutralize each other because salt and water are both neutral, as opposed to an acid having a pH less than 7, a base having a pH greater than 7. Well, now you have something that is pH equals 7, neutral, when you put them with each other. So it's like an acid cancels out a base. These are called double replacement reactions. So all neutralization reactions are acid-base reactions, and they are double replacement reactions. But just remember, not all double replacement reactions are neutralization reactions. If you spill liquid Drano while trying to unclog your sink, what would be a good household product to use to neutralize it? Well, liquid Drano, sodium hydroxide, is a base. So you want to find an acid to neutralize it. Find the opposite. A weak acid would be safer, something like vinegar. Hydrochloric acid is used to disinfect swimming pools, so that's an acid. If you spilled the hydrochloric acid, what would be a good household product to use to neutralize it? You want to use the opposite, a base. And a good household base would be some baking soda. When predicting the products, hydrogen joins with hydroxide to make water, HOH or H2O. The other two elements also combine and they form the salt. Remember that you always write the cation before the anion and then crisscross charges. So remember, double replacements, they go first and last. So hydrogen and hydroxide make my water. Third and second, Na and then Cl is going to make my salt. And then this is +1 -1 cancels. That's why it's just NaCl. So that's my water, there's my salt. You'll often be asked, what is the salt in this neutralization reaction? And so that's how you can tell. In number 2, first and last, hydrogen and hydroxide, that makes your water, right? Third and second are going to make your salt. Third is magnesium followed by sulfate. And then the charges are +2, -2, and that's how we have just MgSO4. Any ionic compound, it can be called a salt. So this is the salt in this neutralization reaction. Fun fact, magnesium sulfate is Epsom salt. So now let's practice a couple of neutralization reactions and then unpause the video to see the answers. So number 1, we're going to do first and last. So hydrogen and hydroxide, HOH, that's water. Okay. Then we're going to do third and second. So third is potassium, second is fluoride. Lastly, we have to go look up the charges of each of them on the periodic table to make sure that they are balanced. So the charge of potassium, it's here, is +1. The charge of fluoride is -1. So +1 and -1 cancel with each other. So this is just going to be HOH plus KF. If we look at number 2, we have first and last. This time that makes our salt, right? So first is aluminum and last is this sulfate, SO4, plus third is hydrogen, second is hydroxide. Hydrogen and hydroxide make our water, okay? So now I need to verify the charges for my salt. And the aluminum is easier to find because it's right here on the periodic table. It has a +3. But the sulfate, I'm going to have to go look at my polyatomic ions list, which is here, polyatomic ions. And sulfate has a charge of, there it is, SO4 has a -2. So this is a +3. This is a -2, and now I have to balance the charges. This, crisscross them, means I need to have a 2 here, and that means I need a 3 down here. And of course, the point of crisscrossing is to balance the charges. 3 times 2 is an overall +6. 2 times 3 is an overall -6. And so finally, you might be asked to identify the salt in each. This would be your salt in number 1. This would be your salt in number 2.